but some more concepts which are useful for class 12 and for competitive exam. So first of all, we will recall of class 11, and they have read that is z is equal to a plus ib. We know that a is a real part and b is imaginary part, like that. And we know about mod of z. Definitely, you can see you can tell very easily. That is square root of real part square plus imaginary part square. And again, also we have read about argument of z, that is, and b is imaginary part, like that. Then tangent of theta is equal. We know about mod of z. Definitely, you can see. We have read about polar form. That is square root of real part square plus imaginary part of that. And again, also we have read about argument. This we will use this in R, that is z is equal and b is imaginary. Like that. Then tangent of theta is equal. We know about mod of z and so many rules for. Also, we have read about polar form and square root of real part square plus of that. And also we have read about argument. This we will use this in R, that is z is equal and b is imaginary. Like that. Then tangent is equal. We know about mod of z and so many rules for. Also, we have read about polar form and polar part square plus of that. And so we have read about argument. This we will use this with z is equal and b is imaginary. Like that. Then tangent is equal. We know about we have read in class 11. But in this conclusion, some more concepts which are very essential for our competitive examination and some more syllabary examination like that. So we have to introduce, we have to extended our concept of complex number in this regard. So first of all, we have to know that is the cos of x and sin of x are the series, and cos of x is equal to 1 minus x square by factorial 2 plus x power 4 by factorial 4 minus x to the power of 6 by factorial 6 and continue. And similarly, sin x is equal to x minus x cubed by factorial 3 plus x to the power of 5 by factorial 5 minus x to the power of 7 by factorial 7 and plus x to the power of 9 by factorial 9 and continue. These are the series which can be defined by the differentiation method in calculus. So this is the part of our advanced technology, our advanced classes like BSc and MSc. But we can read this cos x and sin as well. And one more thing we have reached, that is e to the power of x. And the e to the power of x is, we know that e to the power of x is 1 plus x by factorial 1, x square by factorial 2, x cubed by factorial 3, and continue. So these are the series, exponential series, cosine series, sin x series. So if we want to find e power I theta, If you consider this, then e power I theta. E power I theta will be 1 plus I theta by factorial 1. I theta square by factorial 2. I theta power 3 by factorial 3. I theta power 4 by factorial 4 and so on. But we know that the power of I we can convert in I or minus I or 1 and minus 1. So if we use this formula, then alternate terms, and these are the real terms and these are the imaginary terms. So if we separate them, then we will find 1 minus theta square by factorial 2 plus theta power 4 by factorial 4 minus theta power 6 by factorial 6. And continue. And if the blue colors parts of it is there, then we can see that I will be common and theta minus theta cube by factorial 3 plus theta power 5 by factorial 5 and so now compare. This is similar to this series, but changes is only theta in place of x. So this can be written as cos theta. And similarly, this is I and this is similar to this next series. So, the changes is only for theta in place of x. So it is write as sin theta. So this is the very important formula. E to the power of I theta is equal to cos theta plus I sin theta. This is also called De Morgan's theorem. So definitely you have to note down it and remember it. E to the power of I theta we can write always. And it is our advanced knowledge, it is our extra knowledge regarding complex number. This is called De Morgan's theorem. E to the power of I theta is equal to cos theta plus I sin theta. But also now we will extend this theory again. That is, in place of theta we can write also 2 and pi plus theta, because always the trigonometric form they are equal. So we can also use this there. E power I theta and write as. It means the e power I theta similar to e power I 2 and pi plus theta. So this is our very important theory. What is that? We'll write again. That is e to the power of I theta is equal to cos theta plus I sin theta. So now our theory will be very easy because z is equal to a plus ib we have written. R is equal to mod of z. Theta is equal to argument of z. We have reached z can be written in polar form r cos theta plus I sin theta. So now simply we can write as r is equal to e power I theta. This is also very important form. It is also called Euler form. Euler form of complex number. So now this is our new concept. What is? That is z is equal to r into e power I. Means mod of z e power I argument of z. So it is useful for taking so many things like what is the use? Application. एप्लीकेशन अगर हम देखें इसका, एप्लीकेशन इसका ये है एप्लीकेशन अगर देखें कि some concept nth root of unit. This is a very much useful concept. It is passed in so many competitive examinations, and it is also the part of a state board examination. So now we will read about nth root of unit. For example, suppose we want to find 1 power 1 by n. What is this? Suppose this is equal to x. That means x is equal to 1 to the power 1 by n. So we will again 1. 1 is a complex number, and 1 can be written as e to the power of I 2 and 2r5. 1 can be written as e to the power of I 2r5. When we convert 1 in polar form, then it will be 1. What is the value of x? X is equal to 1 power 1 by n. X is equal to e to the power of I 2r5 divided by 1 by power 1 by n. So e to the power of I 2r5 by n. Now nth root means n. The number of roots will be n, and here the different value we will find for the different value of r. Where r is equal to 0, then first root is equal to 1, and r is equal to 1. 1 will be put in, 0 will put here, then answer is 1. 1 is put here, then answer will be x is equal to e to the power of I 2 pi by n. When we put r is equal to 2, now 2 is here. If 2 is here, suppose this is equal to alpha, then it will be alpha square. Similarly, r is equal to 3, then x is equal to alpha cube, and so on. R is equal to n minus 1 up to 10, x is equal to alpha to the power 4. So we have to remember this alpha value. Alpha will be equal to I into 2 pi power by n. We will see by example also. Alpha is equal to e to the power of I 2 pi by n. And the unit roots are the roots, and roots will be 1, alpha, alpha square, alpha cube, and alpha power n minus 1. Now we will use it by simple method. Suppose we want to find cube roots. So according to that cube roots, 1 power 1 by 3 equal to x cube is equal to 1, yeah, then x is equal to 1 alpha and alpha square. And where alpha is equal to e power I 2 pi by n. Suppose we will somewhere we will use like for cube root alpha can be used as omega. So generally it is represented by 1 omega square. but we can use a simple form. So if we solve it, then it will be cos 2 pi by 3 plus I sin 2 pi by 3, and cos 2 pi by 3, you know that it will be minus cos 120. Cos 120 is cos minus cos 60, that is minus 1 by 2, that is plus I by 2. So this is minus 1 plus I by 2. And then we find alpha square. And alpha square we can find by I square also, we can find by that value also. It will be minus 1 minus I square. So this is the always if we so the cube roots of unity are 3. 1. So even more thing is 1 plus alpha plus alpha square. If we solve it, then always it will be 1. We can check that. 1. Then we will add these two, then this will be cancelled. Then minus 2. So cube roots cube roots हो कुछ भी हो, cube roots हो, fourth roots हो, fifth roots हो. And if we find nth root of unity, then the land with sum of all roots is always 0. This is a very important one. So if nth root of unit are 1 alpha square alpha power n minus 1, then 1 plus alpha square of 2 alpha power n minus 1 always 0. Yes, this is what this is very important. So many useful things we can find also. Cube, but the cube roots of unity. This is very important. Too many times the question based on this concept is asked and that's very important data. Now, suppose one more question will be arise that represent these roots in organ plane. We know that complex number can be represented in a organ plane, and or that real axis and imaginary axis. So we can also represent these roots in organ plane. Suppose this is a real axis and this is the imaginary axis, and there are 3 roots. One is 1, next is which is e to the power of I 2 pi by 3. Its argument is 2 pi by 3, and then the third is first, second, third is e power I 4 pi by 3. So you know that this is argument of complex number. One is suppose this is 1, then first root is 1, this 2 pi by 3 is 120, so 120 angle will be here. So one distance, unit distance, this graph, and this is the second root, and this is 240 will be here, this one distance. So all these roots will be lie on a circle of radius 1 unit, and the angle between every consecutive roots of radius factor will be same. There are 3, so therefore this is 120, 120, and 1. It is also the concept. You can represent a rows in organ plane. It is very easy. One more example, fifth root. Suppose fifth root. Fifth roots of this, if we want to find. Then the fifth roots will be, now simply we can write run alpha, alpha square, alpha cube, alpha power 4. And what is the value of alpha? Alpha is equal to e power 2 pi by 5. And now 2 pi by 5. 2 pi by 5, what is 2 pi by 5 is 72 degree. We can find the roots alpha square, alpha cube by that. Then things that is we want to represent these 5 values in organ plane. Then again we will make one real axis, imaginary axis. Radius is 1. First value is 1. Alpha will be on 72 degree. And 72 will be more than 72 will more than and 72. This way 72 ke are 5 portions we make, and this in this way the first root, second, third, fourth, and this is 5. So these 5 roots will be belong in a set. So this is also a concept which we will use in this. What is the concept? We can represent all the nth roots of unity in an organ plane which lie on a circle with equal angle distance. Now we will read about one more concept, law of complex number. It is also very important. Law of complex number. So again the Euler formula will be helpful because we know that Z is equal to A plus IB in class 11. We have read class 11th R cos theta plus sin theta. It is similar to this. This is called polar form. And recently we have read that Z is equal to E R into E power I. It is very easy for taking out. So what is the value of log? Log of Z is equal to log of R E I power I C. So use the formula of log. Know that log of R plus, according to area of log, this is log of R plus I theta. What is R? What is R? And what is theta? So no, log of mod of Z plus I into R. So this is the concept, log of log. But very easily we can find the log of any complex number. It is very simple. There are two parts. Log of mod of Z is the real part of complex number, log of complex number. The argument of Z will be the imaginary part of log of complex number. Some important questions are there. So many times it has asked in any examination. Suppose the question will ask that what is the value of I to the power 5? Now, suppose we want to find I to the power of I. Now, if you want to find this, so let that I to the power of I is equal to let x. Then log of x is equal to I over log I. And log I can be defined log of z formula as this. What is the formula for log I? Log I, log of mod of I plus I argument of I. Mod of I 1 log 1 0 I. Argument of I is pi by 2. So now this log of I is equal to I into I pi by 2 and this will be minus pi by 2. So log of x is equal to minus pi by 2 and x is equal to e to the power minus pi by 2. So now conclusion is I to the power of I is equal to e to the power of minus pi. And similarly, so many questions we can prove very easily by this formula, which is D Myers theorem. Main motto is D Myers theorem. It's very helpful for so many concepts. Find easy solution. And in competitive examination, it has used. So now this is, I think you all understood this concept, and this is my first lecture like that. Because the condition is circumstances are not there. So when we can take classes in classroom. So it is my humble request to all the students, please accept and catch the concept. Maybe so many mistakes are here in the writing of anything and the pronunciation of anything, but ignore that. Use the concept which I may want to tell. That is D Myers theorem, nth root of relative, logarithm of complex number, and represent the roots in a plane. Thank you.